Hello everyone! In this tutorial, I will show you how to use the Pixelate compositing node in Blender to give your renderings a pixelated look, similar to the retro charm of old video games. Although this tutorial was created with Blender version 3.3, the Pixelate node has been available since at least version 2.79, making this tutorial valid for intermediate versions as well. The rendering engine used for the examples shown here is Cycles. This tutorial applies to both entire scenes and single objects. In the case of single objects, you can even create icons or sprites, sequences of images for animations, on a transparent background. Regardless, the operations required are the same and occur during the node's compositing process in post-production, which takes place after the rendering. For this tutorial, I am using one of my assets, which you can find linked in the description. The asset comes with a single PBR material and a UV-mapped image texture. The scene doesn't have any standard light sources, but it does include an HDR image in the world background. With everything ready for rendering, we can proceed to create the pixelated look. After rendering, open the Nodes editor from the General Compositor section and click on the Use Nodes box to activate post-production. You'll see the render layers output linked to the composite input. Add the Pixelate node by choosing it from Add Filter and placing it between the two existing nodes. In the image editor window displaying the rendering, you won't notice any difference. According to Blender's online documentation, you need to place Pixelate between two distort scale nodes, with the first node having a value less than 1 and the second node being the reciprocal value of the first one. As an example, the documentation uses 0.2 and 5. Using these two values produces an interesting result, but feel free to experiment with different values to increase or decrease the pixel size and modify the result in real time. To interactively modify the value of the pixel size, insert an input value node in the scheme. This node provides a numeric value, which we can use in the second scale node. To use value in the first scale node too, first, calculate its reciprocal by inserting a converter math node. Set divide as the math mode, type 1 in the first value field, and connect the value node to the second value field of math. Finally, connect the output of math to the X and Y inputs of the first scale node. Now you can modify the value of the value node and observe how the rendered image changes in the image editor window in real time. Before closing this tutorial, I want to give you a suggestion. Instead of using a PBR material with realistic texture, try using materials with a toon shader for flatter, less nuanced colors. Also, perform multiple tests with traditional light sources, avoiding global lighting, if possible, to obtain more interesting shaded areas. I'm showing an example of the same object as before, with the changes I just described to the materials and lighting of the scene. That's all for this tutorial. See you soon!